It's the same object.
Actually moving
This, from your point of view, is moving faster and slower. Make it so just at the edge. Try to get your eyes, so you're just seeing the edge of this thing, okay? Now I spin this at a constant speed. So see if you can ignore the fact that it's coming in and out towards you, but just look at it as the white thing is just going back and forth, right? As it goes back and forth, only in that direction. I can't, that's hard. Let me go like this, okay. Huh? Okay, as it's going back and forth, even though it's going the same speed, if I look at it from the top, if I look at it right at the edge, and I just see it going, just like, it's just going like this, right? Okay, so when it goes like this, even though it's going at the same speed, it's going to follow that curve. It's going to be very, very fast as it goes by you, and then it's going to slow down at the edges, because at the edges here, if you're only looking at that direction, it's going a long distance to get to this edge here. Even though it's going the same speed, from your point of view, from it to get from here to here, it's going a long distance. It's going long distance. Over here, it's going almost like in a straight line. But here, it's spending some of its time going inwards to me. But to you, looking at it from the side, only looking at its back and forth motion, it looks like it slows down. So it looks like if this thing is going back and forth. Now, where's our moon guy? Get your moon thing there. Okay. What? As we go around, let's take a little one. As we go around, this thing is going around also. And to the guy sitting at the center, at the Earth, who's watching this, he sees the moon back and forth as it's going around. Come around with me. Keep this thing right over here. So the orbit and Soi is as we're going around nicely, but the real place of the moon is following what this little white thing is. Now the guy who's lying on his back in a nice easy chair outside. Huh? Huh? Yeah, with a warm sweater. It was really cold out. Like that guy doesn't see the moon going in and out this way. He only sees it going back and forth as it's moving this way. It's going back and forth as it's moving this way. So it speeds up when it's going this way like this.
It's revolving around the orbit of the sun.
It's revolving around the orbit of the moon. It's revolving around
Is he the moon?
It has its own
He
orbit.
is the moon.
This is the moon, this little guy here.
What is that street?
Huh?
Going like
This
this.
is where this is, huh? This is the
dreidel.
this guy here, the place where the center of this thing is what's called Mahala and Soi, just like we said before.
That we can measure easily. That
That's
point.
an easy thing to measure.
That
This little guy here is additionally to that thing that's speeding up and slowing down that movement. Because when I'm going this way, it's slowing down, right? Because this guy is dragging behind me. That's
How many times does the moon turn around?
When the white piece is right here.
Yeah,
So I don't need any extra measurements,
That's
right?
correct. Yeah, and when the white piece is right over here, you don't need any extra measurements.
So how many times does the moon turn around in 1 month?
All right, well, I'll give you all the numbers tomorrow. The Rabbah explains them in the other thing, but this is basically the orbit. So the moon is speeding up and slowing down. Now it's slowing down because it's dragging behind me, right? Now it's starting to speed up because it's going faster than my feet are going. So that's the Mahala. That's the Mahala of the moon according to the Rabbah. The Mahala Hamiti. We can discuss this. The Mahala Hamiti is the place where this little guy is, and that is speeding up and slowing down because it is adding and subtracting its back and forth movement to the constant movement of the Mahala and Soi. Does everybody understand that? Huh?
So,
Yeah.
Huh?
so you have to put the two measurements together.
So you have to put the two measurements together. Huh? What do you mean? Yeah.
You want to know where the axis, the
Yes.
orbits,
Oh, it's not
the
exactly the
axis
same,
of
right?
the orbit, you could know. But actually where the moon is the moon.
Alright, so,
another measurement.
Let me have that.
On that
paper towel
that
that is-
axis.
Thank you. Anyway,
So the Mahalach Tzoi is the axis
of this moon's orbit,
Right. It's
and the Mahalach Amiti
is where the moon
moon
actually
is on its
yeah.
own orbit.
Yeah.
And the sun is still going on slowly.
The moon is running around and catching up to the sun in the same way. So basically, we always go through the simplest thing, which is the picture of the Soy, easy to calculate, constant speed every day, constant speed for the sun, constant speed for the moon, and that'll tell you approximately where things are. And that's the basis for the Milo days that we have and everything else like that. That the sun catches up in this 29 days, 12 hours, 44 minutes, and 3 1/3 seconds. But the real Mahalach Amiti for the moon is dictated not only by the fact that it's off-center, the center of the circle is off-center, but there's this thing going back and forth.
What does that
Huh?
affect our view of the moon?
The moon appears to speed up and slow down much more so than just due to the effect
So it
of
doesn't do it for sun.
the off-center. No, it's just it has to do with the moon. And we need this extra precision in the moon because the moon is small and it moves very fast compared to the sun. So this extra precision that's given by having it go back and forth like this to show the speeding up and slowing down is necessary in the calculations for figuring out where the position of the moon is at any particular time. Okay, now I want to give out quickly, I guess our time is up, but if we have another 5 minutes, let me give out these sheets quickly. I'd like to, I'm happy to stay for another 10 minutes or so. If you want to stay, I understand you've all had a long day, and those who wish to stay may stay. I'll stay for another 10 minutes and try to explain some of the stuff. Let's see, these are
You do tomorrow.
Huh? What?
You do tomorrow.
Yeah, we're going to have tomorrow also. I want to do the actual calculations. All right, this is page 6 and 7. We also have page 8. Where's page 8? Okay.
Now, how do
Huh?
now according to when we find out where the position of the moon is?
Yeah.
So now, how do we know what does that affect if the Edom are going to see the moon or not?
Okay. Well, that's a good question. That's the ultimate conclusion of this whole exercise. Now you remember when those two guys are standing over there close to each other, and the moon is shining in the back of the guy's head, and the sun is shining in the back of the guy's head, so that you can't see the moon then. In order to be able to see the moon has to be separated from the sun enough so that some of the light rays from the sun are going to hit a part of the moon that we can see.
You go through this tomorrow?
So we have to know.
I'd like to at least start with page 6 today, if we can. Page 6 is simple arithmetic. Perek Yud Aleph. Not page 6. Huh? Is everybody at page 6? All right, page 6 just tells you how to subtract and add. We've been talking about degrees, right? Everybody understands there's 360 degrees that go around the whole circle, right? In order to be more precise than a degree, we can divide a degree, you could divide it up into tenths, like 0.1, 0.2, 0.3, etc., or hundredths, you could do that also. But it's the common practice is you divide a degree into 60s, which are called, the first one is 60th of a degree is called a minute, and it's symbolized by one little slash at the top. In the Lashon Kodesh, it's called a chelek. This is a different chelek than is used in terms of determining time that we have in the idea of how when we announce the Mailet or whatever. That chelek is really, as I said before, 3 1/3 seconds of time. This is a minute of arc. What they call arc is amount of an angle. A minute or a chelek of an angle is a 60th of a degree. A 60th of a chelek, a 60th of a 60th or 1/3600th of a degree is called a second, just like in time. And then in Lashon Kodesh it's called shniyos, simply because of that. And you can even subdivide that another 60th, and then you'd have what shlishiyos. Anyway,
So there's Ma'ila Chelik,
huh?
Ma'ila Chelik Shnia.
Yeah.
Ma'ila Chelik.
For angles, yeah. But you just have to keep separate the idea of chelik because it's used in both cases and it can get confusing. Chelik in time, we're not going to deal with chelik in time at all. We'll finish with that. The Rambam doesn't even mention it after this particular point. Starting Perek Yud Aleph. Okay. In order to do, everybody probably knows how to do basic addition and subtraction in normal numbers, where you add two numbers together and then you have to go and add and carry it over the next column, etc., etc. Here you have to do it in 60s. And I'm showing you a subtraction example, how you subtract 200 degrees, 50 minutes and 40 seconds from 100 degrees, 20 seconds and 30 seconds. So the first thing you do is you got to start borrowing from your next door neighbor, from the next higher thing. Then you know what I mean by borrowing and subtraction? Where you take 10 from the higher column and then you subtract 1 from that and you add 10 to the 1. Here you got to do 60s. First thing you got to do is, if I want to subtract 30 minus 40, I can't do that. The right-hand column, 30 seconds minus 40 seconds. I can't subtract those because 30 is smaller than 40. So I got to borrow from my next door neighbor the minutes column. I got to borrow a minute from him. How much is a minute? 60 seconds. So that gives me 90 seconds. 90 minus 40, I can finally do that, and I get 50. Then in order to subtract, I now have 19 minutes on top. So I have 1990. Now I got to subtract off 50 from 19. Can't do that. I got to borrow a degree from my neighbor, which is 60 minutes. So I get 79 minutes. So now I can subtract all these things. Now I'm ending up with trying to subtract 200 from 100. From 99 now. So I have to borrow a whole going around. How much is the whole going around? 360 degrees, which is the same as 0 in going around this. Huh? What?
We borrowing that.
It's 60 degrees is the same as 0.
No, you can borrow because you're going around.
I don't have to borrow anything. It's
Right.
there. The 0 is the same as 360. Because I'm just going around the second time. We're going around backwards. 0 is the same as 360. So I just take out 360 and add it to 99. I got 459. Now I can subtract everything nicely and everybody's happy.
Okay.
All right. Next thing, the Rambam says, I've mentioned several times, and I keep on repeating it. You're probably bored with me repeating it. That what we do in this here is we have circles and we have constant speed. Rate times time equals distance. Constant speed times how much time tells you how far it's gone. If you know where it starts, then you know where it is at a future time. So you need to know the starting point. Starting point, the Rambam says, I'm going to tell you these astronomical things as they stood at a particular point during the Rambam's lifetime. When was it? Gimel Nisan 4938, which was like the very close to the first, March 22nd, 1178, it's a long time ago.
438
Huh?
what? The speed of what?
No,
What?
4938.
That was the moment the Rambam chose as being the starting point. And he's going to tell throughout the rest of Kiddush Hachodesh, he's going to tell you a bunch of things about where the sun was, where the moon was, where this bicycle tire was, all these different things. The Rambam's going to tell you where they were at the moment of sunset this day, the beginning of the day, Gimel Nisan 4938. That's what he calls the Iker. Huh? Yeah, that's what he calls the Iker. That's Halacha Tesvav in Parak Yud Aleph. Now I'm just going to do page 6 here, tell you what is